So in your calculator, when you go to y equals, so you have the e, and then the negative 0.35, the x plus 1 in parentheses. You need to make sure that you're arrowing out of the exponent so that the minus 2 is back like in line with the base. And then you can graph that. Get your table of values. So when you hit the graph button, you can see that it has translated. The down part's easy to see because usually it skims along the x-axis. But it has also shifted to the left one. So go to that table of values and get the 5 points from the table of values. So you should have, like your negative 2 should have negative 0.5809. So with these graphs, remember we're not graphing them by hand, we're letting the calculator kind of aid us because of the number e, or the value for e representing the 2.718. So the graph does shift left, it also shifts down, but then kind of using those numbers. Bless you. Bless you. So this graph doesn't show a lot of rapid decay. Points that you're getting in the calculator from negative 2 to positive 2 are all really close together, where generally we have that one point that's way above the rest. And if we would go to like negative 3 or negative 4, we would see those values. But just using those first 5 points that we generally use with the negative 2 to positive 2, the numbers are decreasing minimally. So it doesn't have that huge exponential effect. But this is what the graph should look like, this general shape of the graph. So what would the domain of our graph be? H? Negative infinity to positive infinity. And then the range would be, Sam?
Negative 2 to infinity.
And what part of the equation gives us the range, or helps us with the range?
But the last number.
Yeah, that last number, that's the k value. So the k value tells the graph to shift up or down, and that what helps us get the range. Sarah?
Is there ever a case where the domain isn't negative?
Not for exponential functions, because you can plug in any number for x. There is no limit on the value of putting in for an x when it's an exponent. So for an exponential function, no. There is no change for the domain for any exponential function. So whether it's an e, or a 2 with an x, or a 5 with an x, does not matter. Good question. Any other questions with graphing? So this, like a graph, would be like on that calculator section of the graph, or of the test. When you get to that calculator versus non-calculator test at the end of the chapter. Questions? So the other concepts we're going to look at are trying to work with functions that have the e as the base. So once a value is created, so pi was created, and then like kind of was realized that, wow, pi is actually involved in the circumference of a circle, the diameter of a circle, we can find the area of a circle, we can look at the volume of a sphere, a cone, a cylinder. So, a value is created, and then we realize that we can apply it to all these different things in the world. And that's the same thing with e. So the first two problems here are just algebraic problems. They don't actually involve like a concept, but we can look at some applications that formulas are used or applied with that value of e. So once a value is created, then like it's almost like, wow, okay, we can use this in different areas and not just as an e, but what else is it applied to? So these first two are just like kind of concepts that like it's just function notation. Can you evaluate a function that has an e as a base instead of like a number 2? But f of x equals 2e to the 0.25x, and then it says f of 3.2 is what we're trying to evaluate. So what does that actually mean that you're supposed to do with the problem? Virginia?
Put in 2.2.
Yeah, we're gonna plug in 3.2 for x. So just because it changes with having an e in the problem doesn't mean that the way we solve it is going to change. So in place of x, you're still putting in 3.2. The value that you get out is your y value, your output. So you're plugging in something that always corresponds with the y value, the output. It also makes an ordered pair. If we were looking at it on the graph, this should be a graph, a point on our graph. All right, and what'd you get f of 3.2 equal to? Oh, sorry. I'll call on you next time. Somebody else have it, Virginia?
4.45108.
You just go with 4.45. That's fine. So 4.45, she said 108, and there are probably other numbers as well. But 4.45 is fine. Anybody not get that? I want to make sure that you're using the calculator correctly. The second one down here, just using 5.4 with a different function. So the value for x is 5.4. This function says 3.1 times e to the negative 0.125 times 5.4. So this would be a decay function because that is a negative number with x. So like questions that you'll have to think about, like what makes a function increase or grow, what makes it decay. So when we're talking about the base, the natural base with the e, if it's negative with the x, it goes down, whereas the one above was a positive with the x, so that one goes up. So it doesn't have to be greater than 1, it just has to be greater than 0 to grow, less than 0 to decay. Jason, did you have this one? No calculator today? So I can pick on Ryan then. What do you have?
1.578.
So when you plug in 5.4, you get 1.57. Questions? Pretty straightforward, hopefully. And a lot of it's relying on the calculator. So at the bottom, we have two applications, one at the bottom and then the top of the next page. But this application is dealing with air pressure and air density, which are concepts in like meteorology. So if you look on like the weather app, sometimes they'll tell you what the air pressure is. Depending where you are, maybe they'll tell you about like the density of the air. But this one is talking about, so 60 degrees outside and height above sea level, which is generally how you like reference height. How far are you above sea level? It says the air pressure, which is measured in pounds per square inch, so that's like the pressure of the air like pressing down on us, can be modeled by the equation P equals 14.7 E to the negative 0.0004 H. So somebody found this equation, they calculated it, they created it. So they took measurements, they came up with like this value, and they were like, wow, it actually relates to the value E, that we can make an equation involving this natural base. It says air density, which is like kind of like the dense of the air, the thickness of the air around us, is pounds per cubic inch, can be modeled by the equation D equals 0.0761 E to the negative 0.004 H. So the H in the problem is the height above sea level, wherever you're located. So it says, what is the air density at 10,000 feet above sea level? So these are the equations that if you look on your weather app, that they're using to calculate air density, or that they're using to calculate air pressure. So what do you do if you're trying to find the air density at 10,000 feet above sea level? Well, that's what you plug in for H. So this is the height that would go into the air density problem. So just make sure you're grabbing the right equation. So we've got the density. So there would be the equation, and then the height above sea level would be 10,000 feet. Does anybody know about how high that is? Like how many miles? Anybody know how many feet are in a mile?
5,280.
Oh, good. 5,280. Nice, Sam. So this is a little less than 2 miles. Sam, I must say you impressed me today.
It's first time to see.
No. No. So little less than 2 miles above sea level. So pretty high, somewhere in a mountain. The higher higher you are, they usually say like the less dense the air is. Sam, do you have a number?
No.
Oh, okay. Working on it. Sarah?
Would it be 0.0019?
3.9. Okay. And air density is measured in pounds per cubic inch. So pounds per cubic inch, or inch cubed. So the higher you would go, the less dense the air is. They also say like, visit Colorado. Where's my base? Any baseball guys in here? So like I think there's a lot of home runs where the Rockies play because the air isn't as dense.
Is it really that much different?
Yeah, because it's high.
In Denver, the air density.
Yes, Denver. Yes, yeah, Denver. When they played the Broncos Stadium,
There was a
Yeah.
football
Yeah.
player who didn't play in Denver
because
sickle cell.
and that was one of our players,
Yeah.
the Steelers. Yeah,
And then for track and field, they have to like condition their like a week before they.
so that they get used to the different air density. Yeah, I'm pretty sure at the Rocky Stadium, like I think there are more home runs there because the air density is less. The second question, what is the air pressure at 507 feet above sea level? So this is more of like a normal thing, 507 feet above sea level. So we now want to know the pressure of the air.
0.06.
Oh, Sam has it already.
Okay, so
14.7, not 2.
oh wait, no, I did the wrong. I don't know. Excuse me?
You have anything?
No. I
Oh,
have a question.
sure, I can
On
answer that.
letter A, I did it.
Oh, you know what, it is, because for some reason your calculator is putting in scientific notation. So if you just move, so this just means move the decimal over 3 times, yeah. So, so you'd have 2 zeros and then a 1, yeah, which is exactly the same. Yeah, I don't know why though, but when you get that, you have to move the decimal over 3 times. Do you have that thought any other one?
I know what they're saying.
Oh,
There you go. Yes, yes. Sam, do you have the number?
no,
Oh. Okay.
I thought I did.
Anybody have the number? Kate, what do you have?
12.001 inches squared.
I think it's pounds
Oh, you have pounds per.
per, yeah. What? Oh, I shouldn't use PD. A little brain fart there, I suppose. Why can't I use pounds? Like, why isn't it PD?
Oh yeah, what is a week?
I-
What is a?
I will have to, I don't know, maybe the science teachers don't even use pounds, right? Because that's all like metrics.
Yeah.
Okay, well, sorry about the PD.
I didn't even realize.
I noticed
Well,
it,
thank
but
you.
I noticed it, but it was.
You
I
should
was
have.
like, everyone knows what we're talking about. We get it. We got it.
All right,
See, I just wrote pounds, so like I didn't.
you wrote
really-
out the word
I
pounds.
didn't even like realize.
Thanks. Here I'm like trying to pull in real life Rockies, Broncos, and then I don't write pounds PD.
I like that.
Yeah, then I write PD for pounds. Yeah. You didn't say anything, Grace. Like, come on now. All right, so the last thing we're going to look at then is kind of tying in the chart that you did yesterday. So, kind of thinking about that chart. Here's the chart. Maybe. Here it goes. So this is the chart we did yesterday, where we found that the more times that you compounded our dollar, which is the amount that we invested, eventually the amount that you got pretty much stayed the same. There was like a maximum amount that we could get for our investment. So because of that, the number E was created. And that number E represents the number of times being compounded essentially being infinite. And that maximum value of money that you can earn is that $2.72, $2.72 or 2.718. So if we want to compound interest, or if we want to try and earn the most amount of money possible, then instead of saying I want to compound quarterly or yearly or annually, or monthly, daily, there was a formula that was created, because now we have this value for E, that involves it being compounded continuously, which is the same thing as saying infinitely. Because that's when I can earn the maximum amount. You always want the maximum amount for your dollar. So once it was created that, hey, there's this case happening that if we do this continuously, it creates this natural base of E 2.718, we can then use that number in order to apply that to interest so that you can get the most amount for your dollar that you would be investing. So this formula, we call it the PERT formula, and it would be P, E, and then the exponent R times T. So it's similar with compounding interest, quarterly, annually, semi-annually, daily, but this applies to anything that's compounded continuously, like every single millisecond of the day. It's being compounded. So P is always your initial amount that you invest. R is the rate, and that'll be expressed as a decimal. We want to write that as a decimal. And then T has to be time in years. So any of the interest formulas, there are two of them that you'll have to know. Both of those deal with time in years. Any other formula for growth or decay, it doesn't have to be years. It could be months, it could be minutes, it could be hours. But the interest is specifically for years because it's an annual interest rate over the entire year. So the last two questions here, just kind of figuring out what happens, how can we earn the most amount of money or compound interest continuously. So you invest $3,500 in an account, that gives you 4% annual interest rate, and it says compounded continuously. So you're going to have to kind of look to see what word is being used so that you know which formula to choose. So if the word compounded continuously is there, that's when we need to use this PERT formula. If it said quarterly, then we would have to use the other formula with the 1 plus R over N to the power of N times T. So there are two different formulas depending on the case that you're given. So in this case, Paige, what's the principal amount? What are we investing?
$3,500.
$3,500. And then the rate is
0.04.
0.04. How many years? 1. Yeah, it just says 1 year. So how much money would you have after a year? Kate?
$3,640.
So if you invest $3,500, at the end of the year, you're going to gain an extra $143, which isn't too bad. It's like money that almost free because you're investing it somewhere. And that's the goal of an investment. So in your college account somewhere, like you're earning money, gaining money because of an interest rate that's being applied to it. So the money is sitting there, but it's not just like sitting under your mattress. It's sitting in an account that's earning money. The mattress doesn't earn any money.
Good.
Hopefully your parents don't have a whole bunch of money stashed under their mattress. Because you could easily steal it. I mean, that wouldn't be good. I could see Sam doing that for sure. So the last question here, you deposit $4,800, same type of question. It just pays 6.5% interest. I bet your grandparents have money under their mattress. Pretty sure my grand does. So the rate would be 0.065, and now this time it's 3 years. So the years is always applied in the equation because the longer the amount of time you're investing it, the more money you're going to get. What do you have, Cup? Oh. I'll let you borrow one if you want. Or you're just good. Okay. Anybody have a number? 8? 49.
Yes.
Any questions? Pretty straightforward. Hopefully. Besides the E value being like a new number that you're learning, talking about. So, you have a good bit of time, like 17 minutes. Remember, the homework tonight, I'm going to pass out a worksheet, but it's book homework. The book is up here so that if you don't have a picture of it or you only started part of it, come up and get a picture. It's really on 3 pages. So it is on 3 separate pages. A couple of graphs that you'll have to do. Make sure you have a T-chart for the graph. And then I have a worksheet that I'll pass out. Both of them I'm going to collect from you tomorrow. And the one I collected from you yesterday, your class is graded. I'll definitely give them back to you tomorrow. I just don't have them in the grade book yet.
You agreed on that.
Tomorrow's no, I won't grade it on total accuracy. No.
And you're collecting both?
Both of them, yes. So I'll collect the book homework and the worksheet. We'll just staple them together. And then tomorrow we'll review the 3